Ophir's range of laser power and energy meters has always included both full-functioned, top-of-the-line instruments and basic function instruments geared for more limited needs and budgets. Because of the many recent advances in our lines of sensors, including the beam track, power, position, size sensors, and our Pyro-C line of energy sensors, there's a clear need for a new generation of basic instrument, one that supports all the new sensor technologies we've introduced, while remaining an economical choice. The new StarLite is that instrument. It supports all standard Ophir sensors, including thermal sensors for measuring average power and single-shot energy, pyroelectric sensors for measuring energy per pulse of repetitively pulsed beams, photodiode sensors for measuring very low power beams, as well as our beam track line of sensors for measuring power and position and size of your laser beam. If you need such a solution and don't anticipate using more advanced features such as density, scale factor, data logging, and similar, then StarLite is just what the doctor ordered. Let's have a look. Here we set up the instrument, and we'll start by connecting it to a thermal laser power sensor. After a few seconds to initialize, we get to the main screen. Note the large screen and the sharp, clear readout. By briefly pressing the power button, we can toggle between 3 different brightness levels. Let's first see how we set up the display. We click on the Setup soft key. Here we select the range or scale. We click the Enter soft key and then use the arrow to choose the desired range. Then OK to select. This is the general approach throughout the entire user interface. Note the short explanation at the bottom of the screen for each item. We use laser to select the wavelength. We can use the average function to display a running average over various time periods rather than the instantaneous real-time reading. We could use this function to smooth out jumpy readings so that they're easier to follow. Here, we can set the StarLite to show or not show the settings on the main measurement screen. Here, we set the AC line frequency, depending on the country in which we're located, so that any noise from it can be filtered out. Note the serial number and calibration date information shown here on the right side of the screen. Exit takes us back to the main screen. Notice the ease with which you move from screen to screen. It's very simple and intuitive. Mode allows us to choose between power and single-shot energy mode. OK to select. The Display soft key allows us to choose the display type, bar graph or virtual analog needle. Again, OK to select. We can follow the arrow for a few more functions. Zoom to zoom in on an area of interest. Offset to subtract any fixed background light level. Now we'll switch to pyroelectric energy sensor. Note that we can hot swap the sensors, meaning switch sensors without turning the instrument off and on. We'll only focus on those items that are different. Range and wavelength, as usual. Pulse length. We use this to set the maximum pulse width or integration time of the sensor. We want it to be longer than the width of our pulse so that we don't have any of our pulse cut off and that would result in an incorrect measurement. We don't want it to be any longer than necessary so that too much noise doesn't get in. For those sensors that have a removable diffuser, we inform the StarLite by the diffuser parameter whether the diffuser is in or out. In this case, the sensor does not have a diffuser, so that parameter is not applicable. Threshold. We use this to set the minimum energy threshold below which the sensor will not be triggered. That is done in order to avoid false triggering in situations where we're measuring low energies in an environment that has a lot of acoustic noise. We'll now switch to the PD300 photodiode-based power sensor for measuring very low powers. And again, we'll focus only on those parameters that are different. The range includes the usual power scales plus dBm, which are units that are used in certain telecom and other fiber-related applications. Laser. Here, the user is prompted to select an explicit wavelength. A default set of favorite wavelengths is shown. We can modify any one of those to the wavelength that we need to be working at by going into the Modify screen. Filter in-out. These sensors have an add-on filter which provides additional attenuation to enable the PD300 to work at higher power levels. Here is how we inform the StarLite that the filter is in or out. Now let's switch to a beam track sensor. The beam track series of sensors measures power, position, and spot size, all at the same time. Here we see the power reading in watts, as well as the XY position of the beam centroid and the beam size, both numerically and graphically. It's just as simple as that. StarLite focuses on the basic measurement functions and offers you a powerful, modern instrument that will enable you to perform all your essential measurement work while meeting the needs of a sensitive budget. To get our latest updates, follow us on our website, LinkedIn, Twitter, Facebook, or our blog. All the links are below.